All right, recording has started.
All right, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap. This is a great topic. I'm so excited about this webinar. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use the question and answer tab on your interface and submit your question, and we will be more than happy to address it during the webinar. We also have a very interactive chat feature there, so I encourage you to chat us your questions, comments, etc., anything you want to share, and maybe we'll make it part of the presentation. And then finally, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is how to harden EKS with Terraform and Snyk. Our speaker today is Camille Patrick, who is a senior security engineer at Snyk. Camille, great to see you. Thank you so much for joining me today.
Hi there, great to be here.
All right, great. Well, I'm going to put myself on mute, take myself off the screen, and let you get to what I know is going to be a great presentation.
Awesome, thank you. So, hello everybody. Thank you for joining me in this webinar on how to harden EKS with Terraform and Snyk. My name is Camille. I'm a senior security engineer at Snyk. I work on an infrastructure as code product, so my day-to-day activities revolve around securing infrastructure as code tooling like Terraform in this example. In the past, I used to be a cloud engineer and spent a lot of time doing offensive security. So testing cloud-native solutions, Kubernetes, AWS, OpenStack, and many more. You can find me on GitHub and you can find me on LinkedIn. So let's get started. Why this session? Kubernetes has become a de facto standard for running containerized applications. However, it's quite a complicated beast. It comes with great deal of operational complexities. There is a lot of moving parts, a lot of configurations to make it effective. Here are some snippets from recent security reports. And it's clear that Kubernetes and misconfigurations in cloud are becoming a top risk from security point of view for organizations. Unit 42 from Palo Alto did a great research on identifying vulnerable clusters open to the public. I highly recommend reading that report. So goal of this session, hopefully we're gonna learn how to avoid single point of failures in our configurations. We're gonna showcase some demos on what could go wrong if we misconfigure our services. And we also gonna show you how we can detect some of these misconfigurations early on in development lifecycle. So hopefully catch these bugs before we release them to production. What this session is not about. We're going to spend a lot of time in the console playing with EKS, Terraform, and deploying vulnerable configured clusters. What we're not going to deep dive is on continuous delivery systems in ISC space. If you like to learn more about that, I highly recommend Continuous Delivery for Infrastructure as Code ebook that was recently released by Snyk with cooperation with Engineering Better. You'll find all the details there on how to set up your production-ready deployment systems. We also not gonna deep dive on a specific exploit in containerized applications. There was a recent live webinar done by Matt from Snyk on how to hack misconfigured applications in Kubernetes. So let's get started. What's EKS? It stands for Elastic Kubernetes Service. It's a managed Kubernetes offering from AWS. With AWS shared responsibility model, they taking care of the control plane side of managing Kubernetes for you. Kubernetes can be divided into control plane and data plane. In control plane, there is a lot of moving parts and complexity. there is an etcd key value store that backs Kubernetes configuration. With EKS, you don't have to worry about managing that reliably, scaling that service, and backing that key value store. You also don't have to worry about creating highly reliable and available API services, and you don't really have to worry about any of the control plane issues. What you also get is ability to integrate natively with other AWS services in Kubernetes. So things such as VPC, native VPC IP addressing in your pods, integrating with IAM authentication. So you can authenticate your cluster via IAM service, and elastic load balancing for your ingress. On top of that, AWS also provides managed node groups, where AWS will take care of managing the operating system and the node components of Kubernetes, such as kubelet. They will notify you if your images need to be updated because of a vulnerability that might exist in your system. You can also run your pods on Fargate service. In that case, you really do not even have any nodes because all your pods are running in a like sandbox containerized environment. And what is Terraform? Terraform comes in two parts. It's a CLI tool that allows you to deploy declarative configurations. And it's a language that allows you to describe the infrastructure that you want to deploy. It's highly extensible. It's an open source tool that now supports over 1,000 different providers. Providers are basically connectors to different services, and one of those providers is AWS and Kubernetes, which we'll be using today. It's highly modular, so you can compose multiple resources or units of your services into single blocks and deploy a composable infrastructure. So every presentation needs to have a health and safety disclaimer. So what we're going to do is we're going to be using a lot of console and CLI activities. What I want you to do is to introduce you to AWS Vault. If you don't already know it, it's amazing CLI tool that manages AWS secrets locally on your disk. So in this case, you don't have to store your static credentials, such as API keys, anywhere on your host. Everything is encrypted with your favorite encryption backend. So it could be GPG keys, it could be your keychain, and it incorporates temporary security credentials from AWS to assume roles for you. So you never actually expose your long-lived static credentials anywhere in your console. The only thing that's there is this temporary credentials that get expired after 15 to 1 hour time. So health and safety out of the way. Let's jump to deploying EKS cluster. So there's a couple of prerequisites. Everything we will be showing today, it's available in this GitHub repository, Adversarial Engineering EKS demo deployments. You can find all the resources, the examples and tests. Of course, we need AWS account in order to deploy EKS. We need an IAM user and a role. Throughout this presentation, you'll see these kind of warning signs. Take this as kind of best practices of things not to do in your AWS and Kubernetes environments. So please try not to use the root account user for anything when you're using AWS. When you set up your account, log in with root, then create a new IAM user and a role, generate API keys for that, and store away this root credentials safely, enable MFA, etc. Try not to assign permissions directly to IAM users. Create roles which represent the permissions that required for you to perform an action, and then allow that IAM user to assume that role, preferably through groups. And then please always use secure token service, generate temporary credentials. As we mentioned, there is an awesome tool called AWS Vault that can automate this for you. So let's jump into our first demo. Hopefully you can see my cluster. As I said, everything we'll be doing is in this simple repository that you can see here. Just zoom this so it's more visible. There is a Docker image there that has all of the tools required to replicate the kind of demos that we're going to be doing here. You can spin this Docker image up and have all the tools there. So you don't really need to install anything on your own machine, and you can reuse it between your Linux boxes, Windows boxes, and your MacBooks. So I have my containers already running, and I have some credentials. In there, what we're going to do, we have our Terraform configuration. In order to deploy EKS with Terraform, there is a bunch of resources that we need to deploy. But as I mentioned, Terraform is a composable service, which means there is already modules that allow you to build these services. So this is a Terraform AWS module. You can find these in the Terraform registry. And it takes care of building the entire cluster for you, taking care of required IAM permissions, and it can also deploy your worker groups for you. So you don't actually have to deploy any instances. There is an auto-scaling group behind it that deals with all of that. The only prerequisite for this module is a VPC that has to exist before we deploy this. And luckily for us, there is a module that deploys VPCs. So we're basically going to use these as our kind of default out-of-the-box EKS deployment. There is a lot of default settings there, and we're using this as our base case. So in our repository, let's just quickly jump through them. Default, there is a VPC. We're adding some subnet tags that are required by EKS. We'll touch on those in a second. And there is a cluster module as well, with all of the required configuration. So to show you that this actually works, and now we need to start praying to demo gods, what we're going to do, we're going to execute Terraform Plan. And as you can see, it was quite fast. The Terraform Plan will tell us that we need to deploy around 50 resources to get an EKS cluster. That sounds like a lot, but there is things like subnets, routing tables, security groups, network access controls. So there's a lot of kind of boilerplate that needs to come on top of it. What are we going to do first? We're just going to convert the TF plan to JSON and store it for later use. We'll get to the point why do we need to do this. We called it plan. Name this. And let's deploy it. So in your production environment, you would go through the plan to make sure everything is as expected. And I've been running this quite many times, so I'm pretty sure this does what I want to do. So we're going to just hit apply. Let's just see if it starts. It's running. So deploying EKS cluster takes a bit of time. We're not going to sit around and wait for this to finish. I have a couple of clusters already ready for us to use. So this is almost like a cooking show now. Internally, Terraform provides a kind of free-to-use continuous delivery system called Terraform Cloud. You can sign up to this for free. You've got some capabilities that are available to you for free, which are enough to actually deploy most of the deployments. If you log into my account, you can see here that I have at least 3 clusters running at the moment. Let's click on our dev cluster. There is a bunch of resources that have already been created for us. All I need to do is to grab this name of the cluster so we can log in. In the Docker container, you'll find that there is a bunch of aliases that will make kind of logging into clusters easier for you. But in order to log into EKS cluster, this is the command we need to use. And then we're going to just alias it with EKS demo dev, so it's easier. And then if we do can you get nodes? Hopefully we get some nodes, and it's here. So on this cluster, we have a single node. Let's have a look. What pods do we have running here? As you can see, there is nothing yet running on this cluster. So what we're going to do first, as you can see, I didn't have to jump through any VPN or bastions in order to access this API endpoint. Now, that's a concern number one. AWS takes care of the API service for us. However, and it is responsible for managing its security. So we shouldn't worry about patching it, making sure it's protected from denial of service attacks, and that it should be protected from kind of zero-day vulnerabilities and it's being patched quite quickly. However, it's still public. So what does that mean for us? If we go back to my cluster, there is a public DNS associated with my endpoint. So if I just curl it, what we'll see here is that I get this quite obvious answer from the API server that I'm an anonymous user and I cannot authenticate to this cluster. Now, if you don't know nothing about Kubernetes, you might not immediately associate this with Kubernetes, but if you know enough basics, you can determine that behind this endpoint, there is a Kubernetes cluster. What we can try to do is to try to see what IP address is this sitting on. So there is two public IP addresses on there. On the internet, there is a lot of services that specialize in kind of crawling the internet for known vulnerabilities. Shodan is one of those services. Let's see if we can find something about our cluster by looking at these services. All right, cool. Because our API endpoint is behind a public load balancers, those IP addresses might be reassigned between services. So clearly, when we look at this service, we don't run Postgres there, so we know it's not Postgres. So let's use different service and see what they have to say about this IP address. Maybe they have a different opinion of what this is. So Senses know nothing about this. We do, but they only tell us a single thing. Let's see if there is anything behind this other IP address that we have associated with it. This is a problem with public demos, but we in lack, I think this one has done what I wanted it to do. So as you can see now, we searched the other IP address, and now we get more information about this endpoint. This is what I wanted to show you in the first place. What you can see here is that we not only found the IP address and DNS name that sits behind it, we also found information about the certificates. But not only that, we found private IP addresses that might sit behind this DNS name. The reason for that is AWS will expose some of those public information in the DNS queries behind this DNS name. So now someone knows what's the VPC IP addressing that we're using. They can also see what IP addresses are used to assign to our pods. And that's quite a lot of information. So take that into consideration when thinking about allowing public access to your endpoint. Now, this is a default configuration. We can change that. If we go to the module and we search for public access, you'll see here that this is set to default to true by default, and it allows public access to the endpoint. There is also a private endpoint that you can configure on EKS. By default, it's disabled. So by default, there is no private communication happening. You can switch those around and only enable private access and disable public access. There's a couple of caveats associated with doing that. You won't be able to reach your cluster from like delivery systems that need to connect to API service. So Terraform Cloud is one of those services. In my workspaces, I have a prod cluster that's actually configured to true. And we managed to deploy it, but we had to do one small change to that. We had to disable the management of the AWS authentication on EKS cluster because we were unable to connect to the API endpoint. Now, that's complexity. You will have to solve it in some way in order to achieve this end result. So disabling public access, it's not an only option. You can also limit access to your public endpoint through IP addresses. You can whitelist. By default, this is whitelist to everybody. So that's why services like Shodan and Census are allowed to troll the internet and find these EKS clusters and expose them. And if you have vulnerabilities or unauthenticated access, that can be abused. You can limit that to IP addresses that are known to you. So, for example, your home address, IP address, or your corporate IP address, and make sure that only those services can communicate with them. This can be like a halfway middle ground between disabling it completely and making sure that unauthorized services cannot use it. Keep that in mind. Make it harder to identify your clusters on the internet. Security by obscurity is not great, but locking down your doors makes that much harder for someone to identify that you even have a Kubernetes cluster. So who can access your cluster, even if you decide to leave it public? By default, AWS IAM is allowed to authenticate to your cluster. So that's why we were able to use our access like this. Right, so that's why we were able to use this command. The way this works at the backend is you authenticate to IAM service. The IAM service generates a token for you. You then present that token to Kubernetes as your authentication token. Kubernetes goes and talks privately with AWS IAM and validates that this token is valid. It then needs to link that token to some sort of identity that is known to Kubernetes. The way this is managed, get config map. Is through a config map called AWS auth. If we would look at that config map, see here is we have roles in IAM that are then linked to some identity within Kubernetes. So in this case, the only thing that's allowed to kind of authenticate through IAM is our node pools, and they getting assignment of group system bootstrap and system nodes. These are internal Kubernetes groups, but you can then assign RBAC authorization to the services in order to grant permissions. So that's number one. There is, however, a secret kind of backdoor. The role that we use to generate and create this cluster has unlimited access to your cluster and it cannot be revoked. The only way to do that, it would be to delete the AWS IAM role that was used to create the cluster. Now, that is also not bulletproof. If someone would recreate the same IAM role, they would regain access to the cluster. So we kicked this off on the beginning. Now it's finished. We have this cluster configured. Let's authenticate to it. And then we're going to demonstrate deleting this role and showing you what do we mean by this. AWS. I can never remember these things. EOS2. And yes. live. Right, so we have access get nodes. Good. So there is more nodes on this cluster. Let's jump to this console. In our test folder, we have AWS IAM System Master backdoor. We go in there. Terraform config here. Right. So this is the role that we use to administrate our access. Let's delete this role completely. Yes, I want to delete the role. Cool. So it might take a little bit of time for the service token to actually get invalidated. So what we're going to do to prove that this role no longer exists, and I recreate this Docker container. Let's see if it's going to complain. Right, and you can see AWS Vault in action here as well. What we see here is that this role does not exist. So now nobody could get access to this cluster. We kind of revoked all of the access to this cluster, and we wouldn't be able to regain this access. However, if we now come here and recreate this role very quickly, cool. And might take a minute. Right, so then if we do this, we've got our access back. What else we can do? To prove it that this backdoor is true backdoor, and it cannot be revoked, let's go here. In a test demo, we have a script called delete op-amps. Now, do not run this script on any of your clusters. You're basically going to just trash your cluster and it's not going to be usable afterwards. You would have to kind of recreate all of this. But what we're going to do, we're going to run it. And yep, I want to do this. So we not only deleted the AWS auth config map I showed you before that maps RBAC roles to the IAM roles, we also deleting all of the cluster roles in this cluster. So technically, like nobody should be able to connect to this anymore. But we still have access. And then, as you can see, there is no cluster roles. There is no cluster role bindings. But we still have access. The reason for this is at the back end, whenever you created it, there is a hard-coded config that links this specific role that we used to create with a systems master group in Kubernetes. This group is all-powerful in Kubernetes RBAC. It's a built-in group. You cannot remove it. You cannot revoke it. And it's going to be always there. So the only way to do this now would be to delete this cluster in order to revoke this access. So that's demo number 1. Who else can access your cluster? AWS states that the API server is secure because there is IAM authentication and RBAC authorization enabled by default, and that is true. However, let's just jump to this cluster. Probably. default and trash the cluster, so we need a different one. Can use EKS demo. Right, cool. And then what we can do is, so there is other ways to grant access to your Kubernetes that's not linked to IAM. One way to do this is service tokens. If we go to our service token of example, we have a service account called GitHub integration. So put yourself in the position of your developers when they're on a cluster. They might need to build some features, some integration that needs to link to your Kubernetes cluster to do some automation or magic. And if you're not careful, and if you're not, authorizing this access securely, they can do things like this. They can create a service role, and they can associate that role with cluster role permissions. So, for example, in here, we're gonna associate it with view permissions that grant access to entire cluster. So all we're gonna do, we're gonna create a service account, and then we're gonna create a rollback. Now we have a script called get token. What it's gonna do, secret. Yeah. We're gonna grab that token from the cluster and assign it to our local kube control so that we can use it. So all we need to do is this. Now, in my kubeconfig, user say, let's see. I'm doing this off screen because I don't really want to show you my kubeconfig. Right. What we want is our dev cluster. This. And here, what we're going to do, we're going to change context to EKS demo dev SA. Get pods. So as you can see, we've changed to service token, and because service token has access to some things but not other, we were able to look if there is any pods running on our service. We can see if there are pods running in entire cluster, but for example, we were not able to list the nodes because this service is not allowed to do that. However, what we did is we completely bypassed IAM. So we're now purely reliable on the RBAC of our system in order to protect us. So we kind of breached this defense in depth that, AWS says that our Kubernetes API endpoints is secure because there is IAM and RBAC. Now there's just RBAC. And it's quite easy and common for people to make this mistake, associate permissions with nodes. So you need to keep track of these. And it's not an easy thing to track. Okay. So that's from permission point of view of who can access our clusters. Remember, AWS IAM authentication cannot be disabled. Even if you remove AWS off config, there is still some backdoor information that happens, and that's required for example, nodes as well. So let's have a look at another problem, a multi-tenancy in AWS itself. This is not multi-tenancy within Kubernetes. This is of multi-tenancy in running multiple clusters in the same account. And what do we mean by this? By default, Kubernetes, let's just, what we're going to do. Going to switch back to this. By default, EKS are deployed with quite a lot of permissions, and those permissions are assigned to EC2 instances that make up our nodes as profiles, and those credentials can be accessed through pods by default, and we can prove this by running some tests. So in our directory tests, we have access to MDS pod test. And all it does is just spins up a pod with AWS CLI for us to use. So let's give it a go. Pod. Create, we need to pull the image and the node and deploy. Hopefully our cluster is working correctly and we'll be able to do that. Right, so the pod is running. So what are we going to do? Simply execute a shell within this. Right, so we haven't assigned any permission to the service associated with this pod, but it will get by default access to default service account, but we haven't gone and added any permissions. If we're gonna do this, get caller identity, what's gonna happen is the CLI will go assume the role through our metadata service and get the permissions. What can we do through these permissions? Well, for one, we can describe information about clusters. So here, we are on our dev cluster. If we grab a name of it and run it, now someone in this who deployed this pod, could be application, could be anything. You can find that you have subnets associated with our cluster, but it's like where's the multi-tenancy problem here? It's our cluster, right? So what if we grab the prod cluster name and do EKS do this. As you can see, we can get all the information about our production cluster from our dev cluster. Like we've skipped all of the any boundaries that we could have. The reason for that is if we look at our IAM permissions, so this is IAM console of the account that we are in. If we go and look at the roles associated with our instances, there is a lot of them here. I believe, like, let's just look at one of them. There's these policies that were applied to it. Let's click on the CNI one. And let's have a look at the permission that we get assigned. So by default, any pod that gets created on EKS cluster can attach network interfaces, create network interfaces, delete network interfaces, and it can do that in the entire account. So from your dev cluster, we could go ahead and basically start creating and deleting network interfaces on our production cluster. There would be nothing to stop us there. The reason this works is like the node itself requires these permissions in order to bootstrap, in order to autoscale and create these interfaces. However, the pods shouldn't have that access. So what can we do about this? So one, what you need to do after you deploy your clusters, you need to switch your AWS daemon from using the instance metadata service to using IAM role services. It's a new feature, like it's not new, but it's a feature in AWS that's not enabled by default when you're deploying EKS. What this allows you to do is to remove that CNI plugin permissions from your instance metadata and assign it only to specific service that's used by the AWS node. In that way, even if you leave the instance metadata service exposed, it will be limited to these other services that we cannot really remove. And where did it take us? All right, so we want to go to role, EC2. It's going to get limited to these two. They are less permissive than the CNI plugin because it's mostly just view. It still allows you to gather information. So someone who would break into your dev cluster because it would have lesser controls would be able to enumerate your production cluster. But that's where we are. So ultimately, what we want to do is to disable or limit access to the metadata service in our cluster. So you can do that through Terraform. So let's find where we have these. Inside of this module, there are submodules, and they expose various. So let's go to GitHub. There's module that's required to spin up your node groups. And in there, there is a launch template. And here we are. And what we're looking for is ability to disable the metadata services. Let's see, where did we configure that in our repo so we don't get lost and don't waste time. If we move to Harden in our cluster, right, there are these two attributes that you can configure called Metadata Tokens and put response hop limit. When you change these, like by default, this is set to optional. That means it uses both metadata service version 1 and 2. What you want to do is to change this to required, which means you have to use metadata service 2, and you want to set this to 1. This by default is set to 1, which means the nodes will be able to use the EC2 metadata service to obtain permissions, but the pods won't. We have configured that in our stage cluster. So if we switch, exit this, EKS demo stage, pods. Let's create a new pod, same one that we created before. So Q apply access. We're gonna see it's already there. Q. Yes. So hopefully this is configured as we want it to. CS get color. Right. So the pod were unable to acquire the same permissions that we did in the dev cluster only because we've disabled the metadata services hop limit. So the node can do it, but we can't do. But if on your team you have developers that this kind of thing doesn't deter them and they want to look deeper, as I said, the node can still access the permissions, and there is a configuration option in Kubernetes that allows you to use host networking for your pods, and there is nothing stopping you by default to use it. So if we would go and deploy this, build it node, wait for it to get created. Right, it's running. So kexec it node. And if we do the same thing, because we're now running in a host network, the control that we've put in place of disabling metadata service no longer applies. So this doesn't work for us. Now, if you wanted to disable access to instance metadata on more controllable way, so disabling metadata service does it for all of your pods on the instance. It also requires you to roll the new instances. So you need to destroy the old ones, create the new ones, because the change happens on the launch template mode, and you cannot kind of enable it when it's on. There is another option for you to achieve the same thing. So we've touched on why the multi-tenancy is a problem. There's way too much permissions. The next thing you want to do is build towards zero trust. So we showed you how we can disable IMDS, but it's not bulletproof. There's other way to do this, which is network policies. Project Calico is a CNI plugin for Kubernetes that allows you to enforce network policies. What does that gives you? Let's come here. Let's switch to our dev clusters again. Dev. And in here, what we have is we need to deploy Calico first in order to make use of it. In the directory, you have Calico deployments. There is documentation on how to do this online. It's very simple. It's kind of two operation. There is a makefile in this repo. It kind of does it as well, I believe. Oh, I might be wrong. Install Calico. So if that's on Calico, by default, this doesn't change anything happening on your cluster. It just deploys the controller that that allows you to enforce policy controls. So to prove that, we're gonna exec into this, show you that metadata service is still working as before. Do this. It works. Tests. The network policy that disables this access. So let's go and apply that very quickly. And then if we exec into that container and try to do the same thing, this should be denied now, hopefully. Right, so as you can see, we didn't have to change anything on our instances. It all was implemented in Kubernetes, and we were able to prevent the pod accessing the metadata service without any changes, which is awesome. This suffers with the same problem as disabling the metadata service because the network policy is not actually applied on a host network. So what we want to do is actually enforce that nobody can deploy pods that has host networking. There is very limited use cases where you actually have to do this anyway. But how we can achieve this? So there's another project that kind of enforces controls before they get deployed called Gatekeeper. It uses Open Policy Agent, and it allows you to deny some of these things. So let's go and try to deploy it. Hopefully this is going to work. What do we have here? It's just one YAML file. So, okay, apply. It's going to run. Right. This is the system. This is the gatekeeper. System. Right, it's running. That looks good. That looks promising. In our test directory, we have a bunch of we have gating example. What we're gonna quickly do, I'm running now because we're running out of time and I want to get to the last point. So what we need to do is deploy the template. if everything worked before, this should succeed. This is taking significant amount of time, which doesn't give me. All right. And then we need to apply the constraint. All right. Fit this demo. That is working, which is good. Right, it worked this time, which is good. Let's sync it. Then what we're gonna do is try to delete f test AWS delete first. So what we did in the backend, we kind of implemented a Rego control which says any pod with host networking flag enabled should get disabled, should not get allowed to run. Now this has succeeded. See if we do this again, it's going to work. There's a problem with live demos. All right, here we are. All right, let's see if we're gonna get the deny. If not, you're gonna have to trust me that if you use Gatekeeper, this should get denied, but it doesn't. So you're just gonna have to take my word on this. Where are we? Gating bad pod. Maybe this is gonna trigger it. If not, we're gonna move on. And you have to take my word on this, that this should get blocked. Nope. So, sorry, the demo is not really working out, but when it works, you'll get a deny message that says you basically cannot run this pod. This is not very useful. So this is where Snyk and tools like Rego comes into place. We at Snyk created a tool to manage infrastructure as code and to check these things live. So to showcase this to you, when we start this demo here, defaults ls, we created this JSON file. It's a big JSON file of things that's going to get played. Let's make this clear. Here's Snyk. Let's quickly authenticate. And you go back to your console, you say that you got authenticated. What you can do, you can test this plan. And as you know, when we did it, when we run it, for example, one thing that it did was create a EKS cluster with public endpoint. Now, as you can see here, it gives you the issues before you even deployed it. So you can run this in your CI/CD system, and this will allow you to detect issues. So at Snyk, we generate all of these. You see here, we have insufficient logging. You have public IP addresses mapped to instances. We work to create a lot of these rules. However, you might have situations where you want to check for something specific. And this is where the custom rules come into place. The the gatekeeper example was supposed to link you to OPA. OPA is this language that you can write things to detect early. It's very complicated, but internally in a gatekeeper, there is violations written in this format. And in this example, what we're going to do is we're going to write a custom rule to detect issues on a module, not Terraform resources, but specific module. So we've written this beforehand. It's all available in the repo as well. You use this command to generate a custom bundle. So we've generated it now. Like if you see here, there is a custom bundle there. If we would do Snyk ISE test rules, let's just quickly find where it is. Test custom rules, custom, and run it on our module. Hopefully, if everything works. My parameters are wrong. So we've checked the module, and we have written custom thing that you can make whatever you need to do, and blocked our deployment before it even happened on any custom thing. So I really sad that the gatekeeper object didn't work, because what we wanted to show is how gatekeeper blocks in the deployment and how we can actually make this experience better and detect things early on when you're developing. Hopefully that was useful to you. This is it from my side. You can find slides, I believe, at the end of this session. And that's it.
All right, great. So yes, there are slides. The slides are actually available in the handout section, so you can feel free to download those slides if you'd like. Kem, we have a couple questions in the question and answer tab. If you want to try and get through them real quick, I can give you about 2 minutes.
Awesome. Let's go through them very quickly. So question number 1 from Garrett Gleason. Do you have any reference materials regarding best practices for setting up various AWS accounts? For example, should one set up different accounts for different stages in their pipeline, i.e. dev test stage, or by product line, or by type, or application, etc.? Awesome question. So yes, what I will point you to at first, there is a company that is responsible for a tool called TerraGrant. What I usually do, EKS account production. And that usually gets me to the company name, GrantWorks. That's the name. That's the resource. It's got tons of examples of how to set up different accounts, like what the structure you should use. For example, here you have your root account and you have security, sandbox, dev stage, prod, exactly what you need. What I'm going to do, I'm going to share it in which
in the public chat is probably the best.
There we go. So I'm just going to share it there. There we go. For you later. Hopefully that gives you something to go and read about. So the question number 2. Question number 2 from Maciek Jarosz. Question: how do you protect the system from DDoS attack if private IPs can be acquired via open internet? Great question. So this is the point to where you shouldn't expose the EKS API endpoint publicly. Now, you don't personally have to worry about trying to protect against DDoS when you're using EKS, because AWS takes that responsibility from you. So whatever WAF settings they will use in order to protect you, that's kind of their responsibility to protect you from DDoS attacks. If you're managing your own Kubernetes clusters, I would highly recommend you to make it private. Even for EKS, make it private if you can, or at least limit it to CID ranges of your organization. Hopefully that answers your question as well.
All right, great. Well, we have 1 minute left until the end of the webinar, so I do want to thank everybody who did submit questions. I think we got through them all, but if not, please know that the folks at Snyk will be getting a copy of all the questions, and I'm sure they'll follow up with you offline. Quick reminder that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand. It's also going to be on the Security Boulevard website, so you can go look for it there. Just go to securityboulevard.com/webinars, look in the on-demand section, and it should be right there waiting for you. Real quick, we've got gift card winners for you. Our winners today are Garrett G, Magic J, Natalia C, and Alonzo P. Congratulations to all four of you. We'll be reaching out to you via your email to get your gift card over to you. So please check your email. And if you don't see it there, please check your spam folder. Camille, thank you. What a great presentation. Good stuff all the way around. Really appreciate your time and your expertise.
Thank you very much. It was a pleasure to do this.
Excellent, excellent. Well, I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.